Hello students, Miss Slyman here, and I am super excited to bring you your notes on radian measure because sophisticated mathematicians love radians and we are sophisticated mathematicians. So this warm-up problem is nice and juicy for you. I'm going to leave you to explore it on your own. Look on our student planner for a link to the solution. The hint I'm going to give you is that when you're drawing this out, we're looking for the cosine of DAC in exact form. So that means I'm looking for a ratio. We're not actually trying to find the angle. We want the ratio. All right, let's get into radians. So we already are super comfortable with temperature, and temperature we know can be measured in Celsius or Fahrenheit. Distance could be measured in meters or feet. Well, same thing with angles. Angles can be measured either with degree or radians. And here's how a radian is technically defined. A radian is equal to the measure of a sector angle that subtends an arc equal in length to the radius. Holy moly, what does all that mean? All right, let's start with the vocabulary. So sector angle. Well, first of all, a sector comes from the center of a circle and is like a slice of pizza. So this thing is my sector. Inside of it would be my sector angle. So I'm going to call that theta. And now we want equal to the measure of a sector angle that subtends an arc. Well, arcs are parts of the circumference. So if I'm subtending an arc, that means I'm going to go in between the points where we intersect the arc and trace that out. So subtends means intersects the circle. Oh my goodness, what happened there? The circle to map out an arc. Notice we could have mapped it out this way or gone all the way around. Well, that's the difference between a major arc and a minor arc. Typically, we look at the minor arc. So if I was going to give you some notation for the arcs, I would say arc AB looks like this, and that's my minor arc. Major arc, if I wanted to make sure we knew we were talking about this big one, I would say arc ACB, because those are the points that we trace in order. A segment, so we don't talk about a segment in the definition, but just to have all of our circle definitions in here, a segment is when we put in a chord. So notice a chord is a line that subtends two parts of the circle. So we intersect the circle, and we are not a diameter. So a chord is a line through a circle that does not go through the center. It then creates a segment, which is either the minor segment or the major segment. All right, so back to our radian. A radian is equal. So 1 rad is our notation for the unit. 1 rad is equal to the measure of the sector angle. So this is the angle that creates an arc that's equal in length to the radius. So 1 radian maps out one radius. That's where the word comes from. So let's try and sketch that. So here's my radius. So now I want an arc that's about that same length. So I'm going to trace it out to get a feel for how long it is and then try to do something similar in length on my circle. So that also would have a length of our, whatever the units are, centimeters or what have you. So this angle, I would say theta is equal to 1 radian or 1 rad. Well, that looks to me to be about, I don't know, it's more than 45 degrees, maybe it's 60 degrees. But we can use our circle geometry to figure that out exactly. So let's look at what's happening down here. So here, this angle theta has mapped out 1 radius. So theta 1 is 1 radian. This bigger angle theta has now mapped out 2 radiuses. So theta 2 is 2 rads. Theta 3 is 3 radians. And you get the picture. Well, it looks like 3 radians is about my whole about half of the circle. It's about 180 degrees, so that makes my prediction of it being about 60 look pretty good. But let's keep thinking about what we know about a circle. So if we went the full circle, well, we'd be tracing out the circumference. So my number of radians, so in a full circle, we trace out the circumference. Well, we know a full circle has a circumference of 2 pi r, where r is our radius. So that means in a full circle, when we trace out the whole circle, we end up going a total of 2 pi radiuses. So that must mean the theta of a full circle is equal to 2 pi radians. Well, that also means that in my conversion, 2 pi radians are equal to 360 degrees. Typically, we use half a circle. So I know in half a circle, I'm going to trace out, oh, that's not quite lined up and that will bother me. So in half a circle, that's a little bit better. We would trace out half a circumference. Half a circumference is going to be half of 2 pi, which of course is pi. Half of 2 pi r is half my circumference, which would leave me with pi r as that total measure. So that's pi radians around. So that must mean that angle theta of half a circle, so theta h, is equal to pi radians. So pi radians is half a circle, which we know is 180 degrees. This is the one that I use most often and think about most often, is that pi is half a circle. All right. I'm going to stop this video here and we'll come back and do example 1 together.